Okie dokie. So here is the situation. New project for today and are starting a new multi-day project. The project is some more advanced 3D modeling, and we're going to be making the miniature train. And yes, I know this software is Inventor, Autodesk Inventor, and that's because I haven't made it in Onshape yet, but that's fine. It shouldn't be that much different. And so we're going to be making each of these individual part files. And I think there's 9 or 10 part files, including a piece of track that will be separate part files. And then we're going to do an assembly in Onshape to put them all together and do what's called constraining. And I'm not sure about Onshape's limitations as far as animation, but we'll get there eventually. So this this assembly miniature train thing clearly has multiples of the same part files, and that is clearly not constrained. You only need to make one wheel and one of these axle pegs and so on. And when you make the assembly, you bring in multiples. So don't it happens. Before I made a point to tell everyone there'd be somebody who would make 4, and it's not the worst thing in the world to make 4 part files identically, but just to save some of you some time that would have otherwise been wasted, you only need to make one of these. Okay, and the plans for these are available, same as the plans or the green sheet, and that is from our calendar spreadsheet. Well, first of all, everything's going to be in the all documents, and the PDF is this one, miniature train working drawings. And I'll just make another, come on, load up. There we go. Okay. Copy this file or just make a link for it so it's in the top level of the spreadsheet. So let's do a share, and we'll go down here to here, mini train working drawings, and we'll make that a hyperlink. Nope, that's not it. Thought I copied it. Oh yeah, there we go. And we'll go like this. And give me a second. Let me load up the actual PDF. It'll be easier for me to demonstrate it. Oh, that's not what I meant to do. Yeah, that's fine. And let's make sure to reshare for the meeting. Okay, so here is what's up with the miniature train. We've got 10 different, I think 10, yeah, 9 part files plus at the end. If you take a look at this, which feel free to go ahead and open up the PDF from the calendar spreadsheet. There's 9 part files of the train plus 1 of the part file called straight track. So we're going to be making all those. And they range in complexity from the least complex is the Hitch magnet, which is just a donut. It's easier than any of the parts from the green sheet, up through, I would say probably the cow catcher at the front is probably the most complex. It has a loft where, just like part 7 from the green sheet, where you had to draw a sketch of the back and the sketch of the front a certain distance apart with a new sketch plane and then loft them together. That's how you make this, along with a few other part features. but there are three that are, there are three different pegs. There's a hitch peg, a linkage peg, and a axle peg. There's an axle peg, and there is the linkage peg. That are the easiest way to do it is going to be what's called a revolve, where the sketch you make is actually just sort of the right half of the part, and then you revolve it around instead of extruding in a straight line and like squishing the Play-Doh out of the little star-shaped nozzle. This is revolving it, taking whatever sketch and revolving it around whichever axis you choose. So the difficulty here is, so for this one, the diameter of the shaft of the peg is 0.0625 inches. But when you make the sketch, any of the dimensions that are horizontal, sticking out from the center axis, are cut in half, because when you do the revolve, it sort of makes it twice. So we are going to go through all that. We'll have walkthroughs for all of them. Just paying attention is your goal for right now. And depending on how long we have for all period day, I'd like to do one video. Ideally, we'll make it through all three or at least two of the pegs in this walkthrough recording, and we'll do our best. So first one, we are going to do hitch peg. And for any revolve, the first line you're going to make is going to be your center axis, and then work your way around this sketch. For this, the trickiest part is when you make this line, we don't have a dimension for the length of this line that sticks out. What we do have is a dimension for the peg all the way across. So that means we know the distance from the center axis to the end of this line is half of that. And that's the actual dimension we're going to put in. But we'll start with, well, first, let's go ahead and start with the, let's make a new folder. Okay, a new folder, and let's just call it mini train, miniature train, or mini train. It's all right. And in the folder, let's open up the folder and make a new document. All of the 10 part files and the assembly will be in this folder. So you don't need to call it mini train parts, because it will be the mini train assembly. And let's call this hitch peg and create our document. And let's put this over here, and let's use all of the pixels. No, that's not what I want. Let's go function F11. There we go. Okay, so just like before, we want to sketch on the front plane. It's not super critical, because even though these will be part of an assembly, you just sort of are going to bring them in and constrain them however. But let's just go ahead and do our first sketch on the front plane and look at it straight on, and we can turn off the visibility of the origin plane since we have our sketch plane going the same direction. I am going to leave the origin point on, because I do want it to snap to the center of our part universe, but I'll turn that off as soon as we get the sketch going. Okay, so let's start with lines that we know. So we'll call this our point, our origin point. We can draw this line. This line is going to be straight up 0.65 inches. And this line over here is going to be half of this, because it's 0.25 all the way across. So this horizontal line is going to be half of that. And actually, let me show you a quick, not dimensioned correctly, revolve so that you understand what's going on. Let's do a line from here and another line from here and like this. And I'm not even going to do the arc, but just to show you, we'll finish the sketch and do revolve. And for revolve, we need to choose which which portion we want to revolve, and we need to choose which axis to spin around, where we'll go like that, and you can see how it takes that sketch and doubles it. If we change the axis to revolve around, it would make that shape. Okay, which this sort of looks like the wheel where we're going to do our sketching out to the side. But just to show you what is going on, let's change the axis back. And excuse me, you could do a partial revolve. I'm guessing this is no, it's preview. We can revolve it this much, and you could revolve it 270 degrees, which would be 3/4 around. And you could see what's actually happening. This face right here is what we drew, and it's being sort of copied around. But we need to make the sketch the correct size. So we're going to edit this sketch. And actually, let's go back to the point where we have, let me do all this. There we go. Okay, so we have one vertical line, and this is the one that we're going to make. This is going to be our main sort of foundation line, that from the origin straight up, make sure it snaps to vertical, otherwise it's not going to work. And we'll make that 0.65. So let's go back here and dimension this to 0.65, enter. Okay, and we need to work our way all the way around. The next line, let's work our way around this way and we'll work our way around this way and leave the arc to the end, because arcs are kind of finicky and we want to make sure we have things to snap to. So our next line is going to be the line that sticks out here. And like I said before, if the diameter of the entire shaft of the peg is 0.25, that means this line sticking out is going to be half of that, which is 0.125. Sometimes it would let you actually do the arithmetic in the dimension field. So can you do 0.25/2? Yeah, you can actually do 0.25/2 in the field. Although you probably do that in your head also. So it is 0.125 horizontally. Then we need our vertical line. So far we have this and this. We need to go up 0.5 from the edge here. And we will dimension that to 0.5. Normally, I would just bring out my dimensions sort of away from the center of the part, but because we're going to have some more part feature or sketch feature over in this area, I'm actually going to drag this out of the way. The place that you put your actual dimension lines, dimensions, extension lines, what have you, doesn't really matter, except for that things could get confusing. So the next one is the tricky one that requires some sort of inference. Okay, so we have all the way around this much. Wow, it's sloppy. We have this line, we have this line, and this line. And next we're going to draw this line. But like I said before, we don't know how long this line is. We are not given that dimension. The dimension we're given is the distance all the way across at the widest point of the peg, which is 0.4. So that means the distance from our center axis to the widest point is 0.2. And that's what we're going to actually do. So from here, let's get a new line, snap it to the end of here, make sure it snaps to horizontal, and get the dimension tool. And what is our dimension? Our dimension is the distance from our center axis to the end point of this line. You should be able to, you can kind of see how it's turning yellow. And we can just put it here out of the way, and 0.4 divided by 2 is 0.2. And that gives us our line. And the last sketch feature is just this arc right here, which we know this endpoint is this end, and this endpoint is this end. We just need to connect it. Not that. Is this point is the other end. We just need to connect it. And the only dimension is SR, which is spherical radius, which that's because it's a semi-hemisphere when it's done. But when we're making it, it's just a regular arc. Still going to have the dimension 0.208. So we'll get an arc. Let's get a 3-point arc. And the 3 points are, one point is this end of the arc, the other point is this end of the arc, and then make sure that you have it for arcs. Pointed out before about how arcs are finicky, where if you go past halfway and put in the correct dimension, which is 0.208, it will, well, that one broke because I actually did it super wrong. But the key is just make it slightly arced in the correct direction, like that. And then we can actually dimension it to 0.208. And that's our sketch. We're going to finish sketch and do a revolve. Okay. First thing that it's looking for is we need to choose which sketch, which is the main thing. And now we need to choose which axis. So we can click on that and click on our vertical line that we planned on being the axis the entire time, and check mark. Okay. And we can turn off the visibility of the origin point. It's not doing anything. Okay, so while this is fresh, let's go ahead and do the linkage peg. We'll save the axle peg for another one. It has some other features going on. Linkage peg is the tiny one, which you can't really tell because it's not to scale. It's this one right here, part number 8. And it's very similar. It's actually missing a dimension, I believe. So we will have to eyeball it, which is a rare circumstance. I think. Yeah, I don't think we get that widest dimension, but either way, we'll make it look right. Linkage peg. And we're going to start the same way. We'll go back and look at the dimensions in a second, but let's start a new sketch on the front plane. We can turn off visibility of these planes. And so that's what we're looking at now. And so once again, our first line is going to be our foundation line of what we're going to use as our axis of revolution. And so we're going to draw a vertical line that everything's going to click to, and it needs to be, is it 0.325? Yeah, 0.325 tall. Let's go ahead and do that. Line tool from center, make sure it snaps to vertical, and dimension the length of that line to 0.325. It's going to get super tiny, and so that means we need to zoom in. Okay, and our next line is going to be from the center out, and we can do right click, escape line. And so this one is super tiny. It's 0.625 all the way across. So half of that is 0.0625. So that's 0.03125, I think, but that's fine. We can just do dimension this line 0.0625/2, and it will do it for you. Okay, and next one is this vertical line on the outside, which is 0.25, just like the one that was 0.5 before. So we'll get a line, we'll go straight to vertical and dimension this 0.25, and we can get that out of the way again. And this next line, just kind of from the end of this point, just make sure it snaps to horizontal. And like I said, the drawings are actually missing that dimension. All we know is that the arc from the top of everything to the end of this line that we don't know the length of connects and has a radius of 0.1562. And so we're just going to make that arc right now. We just need to make it look close, and you'll see how we can adjust it later. But we need our 3-point arc and connect from here to there, make it look sort of roughly close, just sort of generally arced in the right direction. And dimension tool, click on the arc, 0.1562. Is that what it was? 0.1562, and enter. And it's still blue. And the reason why it's still blue is because we don't have a dimension for this point, which should be able to slide around. Why is that like that? That should. All right, well, we'll just go with that. Maybe this is the maximum. I don't know. So long as the height or the arc doesn't go up before it goes down, it's fine. If it goes up before it goes down, it will make sort of a dimple on the top. But something that looks like this, let me actually dimension, and I'll just tell you a dimension that will work, which is, let's just make it 0.1. Yeah. Okay, so let's call the length of this line 0.1, and that's, even though before we did the distance from the end point to the center of everything, which this will over dimension it. That's why it's grayed out. But if you just make this line 0.1, you'll be fine. Let's finish the sketch, do a revolve, and choose the loop that we want, and choose the axis. Well, you got to click on this red bar so it knows you're choosing the axis, and it's going to be this one. And we'll finish the revolve, and that is it for linkage peg. Okay, so we can end the